Well, good morning, class. I hope everyone is fine. Our topic for today's class will be functions. So, starting functions, first of all, we need to know what functions basically are. The definition of functions in mathematics is basically that function is a relationship between a set of inputs and a set of permissible outputs with the additional quality that each input is related to exactly one unique output. Let's start the written work. First of all, we'll put the heading first, functions for the topic. Functions, maths. First of all, we need to define functions. Function is a relationship between a set of inputs and permissible outputs. Permissible outputs with the additional quality that each input is related to a unique output. That means that if we input something into the function, it would only give us a unique answer. Different inputs would give us different answers. They would not give us the same answer in any case. It would not be a function then if it gives us the same answer for different inputs. Unique output. Let's take an example for this. For suppose, let's take the equation y is equals to x plus 4. Well, I'm assuming that every one of you knows how to plot these linear equation. It's a linear equation. Y is equals to x plus 4. Firstly, we need to draw a grid. X plus 4, x means that it has a positive gradient, 4 means that it would pass 0.4 over here. It would be 4 or minus 4 over here. I'm assuming everyone knows how to plot graphs through the previous videos that you have already watched on this channel. So this is the line of the function y is equals to x plus 4. In this case, each value of x, as we move on to the x-axis and the y-axis, each value of x would give us a different y. For suppose if we are on where x is 0, it gives us the value y4. We can check this through the vertical line test. For suppose we move on to x is equals to 1. We draw a line over here, vertical line, x is equals to 1. It only intersects the line y is equals to x plus 4 at a single point. That gives us y is equals to 5. So it means that when we enter in f is equals to x plus 4, this is how we denote a function basically. When we enter x is equals to 1, that would be f1. It would be 1 plus 4 is equals to 5. Now whatever the case, whatever we put in this, it would give us a different value of f of x basically for the function. When we put f2, it would give us 2 plus 4, which is 6. Well, in any other case, it would never give us 6. When we put f is equals to minus 2, f of minus 2, it would give us minus 2 plus 4. That would be 2. In none other cases, it would give us 2, despite when we put minus 2 in the function. So this is a function. When we put minus 4 in the x, it would give us 0. We can also check that. Minus 4 is equals to minus 4 plus 4. These cancel out, it would be 0. You can see it on the graph as well. Okay, let's move on. Well, this was how we denote a function basically. The notation is f of x is equals to y. Over here, this f means the name of function. You can say the function's name. You can use any other letter instead of f as well. Function's name. This x over here inside the parentheses, inside the brackets, means the input that we are going to give into the function. And this y over here, this means what the output is going to be, what the output is going to be. Okay, so I think this is clear enough. Now we should move on to some other examples. I should be changing my page. Okay, that's good. First, suppose we choose the function f of x is equals to x squared. Okay, we can also write it as y is equals to x squared. From the previous lectures, you would definitely be knowing how to draw this graph. This is a very basic graph in mathematics. This is a parabola shape. For your kind knowledge, parabola. This is the origin point, the x-axis, the y-axis. This is the -1, -2, 1 and 2. These lines move on to infinity because this is a parabola. Keep on increasing. The domain of the function, we'll talk about that later, is all real numbers. So in this diagram, in this graph, we can see that for the value of x is equals to 1, there is a different value of y. For x is equals to 2, we have a unique y. No other value of x would give us this particular value of y. No other value. This is a function. Okay, we can also check this through the vertical line test. For example, x is equals to -2. X is equals to -2. It only crosses the graph at a single position. So this passes the vertical line test. So this basically is a function. Similarly, we should take another example to differentiate equations from which are functions and which are not functions. X is equals to y square. Let me simplify it for you. Y is equals to plus minus under root of x. So the graph of this equation would basically be of this shape. 0, this is 1, 2, 3, 1, 2, -1 and -2. When we apply the vertical line test on this particular equation, like for example where x is equals to 1, the vertical line crosses the graph at 2 positions. That means when we put it's f of x is equals to plus minus under root x, when we put f1 over here, it gives us plus and minus, two values of plus and minus 1, two values of y. When we put f1, it gives us 1 and -1. So it's not a function because it gives us two different values of y for a single value of x. We can check with 2 as well, with 4 as well. 4 is basically a square root, so I'll show it and make it easier for you. When we put f4, it would be plus minus under root 4. Under root 4 is 2, so it would be, when we put 4 into this equation, which is not a function basically because it has different values of y, it would be plus 2 plus minus 2. So 4 gives us plus 2 and minus 2. It gives us two values, so this is not a function basically. Let me make it more simpler for you. For example, let's take an informal example. F is let's make any example a silly one. Fruit, let's make mango.